Hello, this is Jack Jackson. In this video, we're going to talk about using a continuous CDF and do probability computations if we're given the formula for the CDF and making use of the power of our graphing calculators. If you recall in the previous videos, previous examples, we have seen that if we are given the graph of the CDF, then we can find probabilities and inverse probabilities by simply reading off x and y coordinates of the graph. So one way we can do this equivalently on a graphing calculator is enter the formula into a graphing window, say y1 equals the CDF formula on a TI-84, or f1 equals the CDF formula on a TI-nspire. And then we could use the graph to help us compute probabilities and inverse probabilities. Now remember that the y values on a CDF graph always go from 0 to 1. So these limits from 0 to 1 should be your y limits on your graph, or maybe slightly beyond. And when we're using a TI-84, I like to have a little bit of space at the bottom of the screen, so if I do anything like a calc intersect or a trace or something, the display down there at the bottom will not be on top of my graph. So what I end up always using is negative 0.2 for y min and 1.1 for y max, and that covers the 0, 1 and leaves a little bit of room at the top and a little bit bigger room at the bottom for the graph. If you have the new color TI-84, then actually just 0 to 1 works pretty well, because when it does the calculations, it does it outside of where it graphs for the display. And nspire, this works pretty well too. So this is a pretty good window though, negative 0.2 for y min and 1.1 for y max, and it's a little bit of trial and error to find the appropriate window for the x's. So let's start with this example right here and see if we can get a graph. So how do we know it's a legitimate CDF and get a graph? Okay, so let's do that first, then we'll come and see if we can answer these probability questions after that. Well, it's a formula. We know how to graph formulas for any particular formula. So on a TI-84, let me actually bring up a TI-84 emulator here and show you how we would do this. So first of all, we type in the formula. You go to y equals, clear out anything I may have in there, and I do 1 divided by parentheses 1 plus 2 e to the x's right here, e to the power negative 0.3 x, close the power, close the denominator. Okay, that should do it. So that looks like this screen. Now we got to come up with an appropriate window. Well, I don't know. I've got it set something. I'll just leave it what I've got for right now. But the y's I know need to go from negative 0.2 to 1.1, and I might as well go up by 0.1. So these three settings right here I would always use for a CDF. Now when I graph it, what I should see is a graph going from 0 to 1. We're getting close to 1, but we're not anywhere close to 0. So I need to go out further, definitely to the left and a little bit to the right. Let's see where I am right now. I'm 10 on the right. Let's go out further, maybe 25 on the right, and maybe 20 on the left, negative 20. If I want to do that, I might mark it off in not 1s, but maybe 2s or 5s or something. Let's say if I go to 25 here, maybe mark it off every 2. All right, that's pretty good. That's kind of the graph we'd expect to see. We expect to see it about 0 or approaching 0 at least on the left, approaching 1 on the right. And if it does that, increasing the whole way or at least never decreasing, then that has to be a legitimate CDF curve. So that's how we know it's a CDF curve, and that's how we get the graph. And so you can see it there. Now notice that the window settings were exactly this for the y's always for a CDF, but we had to do a little experimenting. If this stays right at 0 a long time and then sort of shoots up almost vertically to 1 and stays there a long time, we can probably squeeze it in a little bit on the sides and have a higher y min and a lower y max. But if we, like I saw the first time, if it was not quite, well, let me just show you. if this was only, say, negative 5 to 10, let's try that. Notice it's not getting all the way down to 0 here, nor is it quite getting all the way up to 1. I need to expand it out. I need to go further left and further right. Well, what if I do overkill? What if I go negative 50 to 50? Okay, well that will work, but I've got a whole lot of screen right here that it's 0 and a whole lot of screen that it's 1 or almost 1. So in this case, I could probably come in a little bit closer, maybe in here somewhere and in here somewhere. And that's how I kind of just trial and error came up with the window of negative 20 to 25. And this is not a hard and fast thing. If you wanted to go, you know, negative 18 to 24 would probably work, or negative 20 to 26, or, you know, there's several things that we could do, but it should kind of look something like that when we're done. And just most of the PDFs look something very similar to CDFs look something similar to that. Okay, now how about on the Inspire? How do we do some graphing on that? Let's go ahead and pull up an Inspire as well. And so in the Inspire, I have a here's a graphing thing, and if I do Control G, that takes me to the list of functions, and I have something in there now which is not what I want. So let me just get rid of that. And let's type in the formula that we have here. Let's see if I can see it. Okay, it is 1 divided by parentheses 1 plus 2 e to the power. Now I'm in the power, so parentheses around the power are optional here. Negative 0.3x. And that's our function. Hit enter and it will graph it. Now once again, I can see that I'm not far enough to the left or to the right for this to work. So I'm going to use the same window settings. To get the window changed, I go to Menu, and then I go to Window Zoom and go to Window Settings. And if we use the same settings, I believe it was negative 20 for X and 25 for Y, negative 0.2 for Y min, 1.1 for Y max. The auto scaling is fine for the tick marks. And boom, there's our graph. And it gives you the formula right there. And you can, if this is in the way, you know, you can move it around like that. So there's the formula, and which gives us a graph. So we can just get a graph. We can see by looking it's a legitimate CDF graph. Now, let's do some probabilities. How we do the probability is less than 5. Well, that's when that just means it's the CDF of 5. Now I'm going to show you 3 ways to do this on both calculators here real fast. So this kind of problem is pretty easy. Once you have the formula in for Y1, you can do it from the graph by doing a trace. Trace. Now we can move our arrows around, but we may not get it to land exactly on x equals 5. But if we just type in 5 after we've done trace and hit enter, it will go right to the point and show us on the graph and shows us the x value is 5, and there's the corresponding y, which is the probability we're looking for. That's the probability to the left of 5. Now, we can also do it from a table. As long as we go to table setup, going up 0 by 1 should get me to 5. I just need to make sure I see 5 in my table. So now if I go to my table here, notice that when I go down here to 5, the y value there, and notice when I put my cursor on it, I see more digits down here. That's our same value. The calculator also knows function notation. So if I get out of here, I can just say y1 of 5, like this right here in this middle screen. Now, to get the y1, watch this. You hit variables, right arrow to y variables. Number 1 is function, and there it is, number 1. And then you say parentheses 5 parentheses y1 of 5. Let's do that again. That's variables, right arrow to y variables, function, and then it's the first one, y1 of 5. Now, there's also, if you have the newer, well, what I just showed you works if you have a TI-83, works on a TI-82, works on a TI-84 with the older operating system or the newer operating system. But if you got the newest operating system on a TI-84, there's another shortcut. It's F4 up here. So do alpha trace, and you'll see a quick way to get to Y1 there. And then you can say Y1 of 5, of course. And that gets it for you. You could do the same three things on the Inspire. So here's the Inspire. I could go to here and go Menu and Trace and just say Graph Trace. And then I can just type in 5 and enter. And it goes to the point and it gives me the coordinates. Unfortunately, it's not giving me very many digits there. Okay, so maybe a better way would be to look at a table. The table you can turn on and off by doing Control T, T for table, Control T, and there it is. And if I go down to number 5, there it is, and you can see some more digits down here. So there's the table there. I'm going to turn that off by doing Control T again. That turns it on and off. So Control G hides and shows where the formulas are. Control T hides and shows where the table is. But I could go back to the home screen, which is 1.1 here. So Control left arrow, Control left arrow. Okay, go back to here, and I can either type in, since I know this is F1, I can actually do it a couple ways. I can type in F1 of 5 like that, and just type it in that way. But I could also get F1 by hitting variables. Notice here some programs I've put in, functions, but also F1 is the formula that I have in. I can click on there and say F1 of 5. And it gets it there as well. So the home screen is probably the easiest in both cases. So once you have this formula in, say as Y1 or as F1, then just quit, go to the home screen, pull up Y1 of 5. That's the easiest thing to do. And you get plenty of digits there. Especially if we're going to do different kinds of calculations. So the next calculation is, see if you can figure out how to do the probability that x is greater than 7. That's the next one. Well, x is greater than 7 is 1 minus the probability that x is less than 7. So that's 1 minus the CDF of 7. So again, you have your formula in Y1. The easiest thing to do, since you've got to do a 1 minus, is just do the whole thing from the home screen. And that would be like this. Since I already have it in, I can just do 1 minus variables, y-vars, function, y1 of 7, like that. So again, the probability that x is greater than 7 is 1 minus the probability that x is less than 7, which is 1 minus the CDF of 7, so that's just 1 minus y1 of 7. And similarly, you can do the same thing on the Inspire. Let's see, get my Inspire back up here. I've got the function in as f1, so it's 1 minus f1 of, was it 7? Yeah, 1 minus f1 of 7, and then enter, and that's the same. So there's the probability that we're looking for. Let's see it there. Okay, next. The next probability we want us to figure out is the probability that x is between 4 and 8. See if you can do that one on your own. Between 4 and 8. Okay, well, between 4 and 8 is, again, we've got our CDF in Y1, so it's just CDF of 8 minus CDF of 4. And again, remember, it doesn't matter whether these are or equal to's or not. So we don't have to worry about some things that we did in the discrete cases where we did this, but we had to worry about whether or not we were including these endpoints. So this is just y1 of 8 minus y1 of 4, and or f1 of 8 minus f1 of 4 on the Inspire here. Okay, now let's give you an exercise, and this time, now that you've seen an example, let's have you do this, and we'll come back and check. So let's see if you can work out let's say the first three of these probabilities. We're given a new CDF formula. This is actually a piecewise defined function. It's 0 for x is less than 5, 1 for x is greater than 10, and between 5 and 10 it follows the formula 1/25 x minus 5 squared. So take that CDF formula. First of all, graph it and convince yourself that it is appropriate CDF formula, and then figure out these first three probabilities and then come back and check when you're ready. Press pause now. Okay, well, here's the graph. Notice that to the left of 5, we've got 0. To the right of 10, we've got 1. And in between, it increases from 0 to 1, and it is one continuous piece. So that is a legitimate CDF. The only part that we really need to be concerned with is the part really from 5 to 10. So what's the probability that x is less than 4? Well, that's over here in this first part where all the probability is 0 to the left there. So that's 0. And the probability that x is less than 10 or x is less than 11 or 12 or any of these values from 10 on to the right, the probability there is always 1. It's just the CDF value there, which is 1. The probability that x is greater than 10 or greater than 11, this probability to the right here is the distance this is from 1, which is 1 minus 1, which is 0. All right, what about the probability? And by the way, notice that those we didn't really have to pull out any kind of calculator or anything for that. They were pretty easy ones to look at for the extremes. But now what about some probabilities like the probability that x is less than 7? Okay, let's do probability that x is less than 7. See if you can do it yourself. Press pause. Come back when you're ready. Well, for x is less than 7, we're basically, remember, a less than probability is exactly what the CDF does. So it is just the CDF of 7. So for 7, we're using this part of the formula. Here it is worked out without a calculator. You just plug in the 7 in place of x and work this out. 7 minus 5 is 2. 2 squared is 4. 4 times 1/25 is 4/25 or 0.16, 16%. But of course on the calculator, once we have our formula in, we put our formula in like this, 1/25, and then x minus 5 squared is y1. And in fact, we could just put it in like this and only graph it then from 5 to 10. And then we see it increasing from 0 up to 1. We use our standard window of negative 0.2 to 1.1 for y's, but we only graph it in the part where this formula applies. Now, as far as the calculator goes, this formula is going on up here, and then I guess actually this place it turns around and goes back up this way for a parabola, but the only part that this formula applies is between 0 and 5, so we're not going to use this formula off screen. Okay? So as long as we're only using it for x's between 5 and 10, this is going to work out just fine. We don't have to actually graph the horizontal pieces. So anyway, we just find the probability that x is less than 7. We're finding x equals 7 here, and then finding the y value, which is, we can see is about 0.16 on the graph, and we can see it from the calculator as just y1 of 7. Similarly, in the TI-nspire, we could put in f1 equals this, and then just from the home screen do f1 of 7. How about the probability x is greater than 8? Figure that one out and come back when you got it done. Press pause now. Well, a greater than probability to the right is always going to be a 1 minus the CDF. So the probability that x is greater than 8 is 1 minus the probability that x is less than or equal to 8, which is 1 minus the CDF of 8. If we had to do it without a calculator, we could do it with a formula by plugging in the 8 here. 8 minus 5 is 3, squared is 9, times 1/25 is 9/25. 1 minus 9/25 is 25/25 minus 9/25 is 16/25, which is 0.64. Or we could just do 1 minus y1 of 8, which is 0.64. And you could even change that to a fraction in your calculator as well if you wanted the 16/25. All right, one more. How about the probability that x is between 6 and 8? See if you can work this one out and check your answer here with me in just a minute. Press pause now. Well, it's a vertical distance here between between these values. This is a little bit out of whack. Let me fix that. Okay, that's lined up a little bit better now. So we find the 6 and the 8 here on the graph, and we're finding the difference between these two y values. In other words, the vertical distance between this little purple and orange lines, this green distance right here, is what we're looking for graphically. But algebraically or numerically, it is just the CDF of 8 minus CDF of 6. So plug in 8 here, plug in 6 here. They're both in this middle piece, so it makes sense. And so we use this formula for them. 8 minus 5 is 3, squared is 9, so this is 9/25. 6 minus 5 is 1, squared is 1, times this is 1/25. 9/25 minus 1/25 is 8/25, or 0.32. You can do it on the calculator as just y1 of 8 minus y1 of 6, which is 0.32, and if you want to change that to a fraction, you can. Change to a fraction is just math, and then enter. All right, so we've had some practice now computing probabilities given the formula and using our calculator to do the grunt work for us. So we didn't actually have to do this by hand. We could have the calculator do it for us. In the next video, we're going to come back and do inverse probabilities from the calculator using the CDF given the CDF formula.